Hi, pre-calculus students. Welcome to section 5.3b, solving trigonometric equations. We will be looking at two more strategies where your angle is not just a theta or just not just an x, where it would be a multiple angle or a half angle, something like that. And what I do is I deal with those two things separately. I first deal with the trig function and then I deal with the angle. And we're also going to look at where we need some substitution using trig identities, right, from section 5.1 and 5.2 before we start solving. So I'm going to go ahead and share my screen. Here we go. We are now in the same notes, but on E. So the way I handle problems like E and F. So it says sine of 2x equals 1/2 for E and cosine of x over 2. Sorry, that looks a little funky, but that's cosine and the angle is x over 2 equals a negative square root of 3 over 2. So the way I do this is I first take care of the trig function. So by that I mean on E and F, I first substitute the angle for theta. I solve the equation. I replace theta with the correct angle and solve for x. Okay, and so I use that again for E and for F. Okay, now the reason why I do this is I am really good at knowing that's where sine of theta is 1/2, right? That first starts at pi over 6, right? That I get. If this were sine of theta equals 1/2, I could solve that. My problem is the 2x. So the first thing I do is I set my angle equal to theta. So I substitute, and I'm first going to solve then for sine of theta equals 1/2, right? So let's go ahead and get our solutions for that. We know where that happens. That would happen at sine is first theta, right, at pi over 6. Let's do degrees. Let's do at 30 degrees. And then that happens again. Sine is also positive in the second quadrant. So that would be 30 degrees away. So that would be at 150 degrees, right? And then any number of 360 degrees. There we go. So now that I have solved for theta, I can now say, you know what though? My theta was really 2x, right? Notice now my trig function is gone and I just have angles. So now I can work with the angle 2x. So where I have a theta, I'm going to put in 2x. 2x equals 30 degrees, 150 degrees, and 360 degrees times n. And now all I have to do to solve for x is divide everything by 2. So if you notice, I took care of the trig function first, and now I can solve for x. X equals 15 degrees, 75 degrees, and those occur every 180 n. So again, my method was to first set the angle because it was not just x equal to theta, solve the trig equation for the angles, then put my original angle back in and solve for x, right? If you put 15 degrees or 75 degrees into your original equation, it would be true. Okay, let's go ahead and try the next equation. Again, cosine of x over 2 equals a negative square root of 3 over 2. I would be just fine if this were cosine of theta equals a negative square root of 3 over 2. I know cosine is negative in the second and third quadrants. I know that it's a square root of 3 over 2 at pi over 6, right? I'd be just fine. Okay, but my angle is x over 2, and that's really bothering me. So I'm first going to say that my angle x over 2 is equal to theta. And I'm going to solve cosine of theta equals a negative square root of 3 over 2. This I know how to solve, right? I'm going to draw myself a little picture here. Haven't done that in a little bit. We said cosine is negative in the second quadrant and the third, right? And on my left hand, where is cosine a negative square root of 3 over 2, right? That happens at pi over 6. So I'm at pi over 6 in the second quadrant and pi over 6 in the third quadrant. Okay, so what are these two angles then? These two angles are 5 pi over 6, 7 pi over 6, and those occur every 2 pi n. I could have done degrees. I decided to do radians this time. Okay, so now that I've taken care of the trig function, right, I can now say that my angle, it wasn't actually theta, it was x over 2. So my theta was x over 2, and now I can solve for x. Let's take a look there by multiplying everything by 2. I've kind of run out of room, so I'm going to list all the solutions right here. X equals, let's see, the 2 cancels and leaves a 3 in the denominator, 5 pi over 3. My 2 cancels and leaves a 3 here, 7 pi over 3 plus 4 pi n. There we go. And here's my final solutions. If we checked those in our original equation, they would be true. Let's look at G. G is probably the most difficult, right? And what happens is we have 2 cosine squared equals 2 plus sine of x. It is okay to have 2 different trig functions in the same equation. But if you cannot separate them into one trig function set equal to a value, then that is our issue, okay? So what I'm suggesting to you here is that I have a cosine being squared and a sine, and I can't get either of them just set equal to a value. So notice with my sine of x, if I subtracted a 2 from both sides, now sine is dependent on cosine squared. Notice if I took the square root of both sides to have the square root of 2 cosine of x, it would be dependent on the square root of sine of x, and that does not sound like any fun. So here's my suggestion to you, that we need a substitution using a trig identity. Now, because I cannot substitute sine with something in terms of cosine, however, so I am looking at a Pythagorean identity. We do know that cosine squared is equal to 1 minus sine squared. I do not have any trig identity that relates sine directly to cosine that's going to help me. So what I'm going to do is, where I see cosine squared, I'm going to replace it with 1 minus sine squared. So here we go. 2, 1 minus sine squared. Now that I have all sines in my equation, I think that I might be able to solve this. Okay, I'm first going to distribute the 2. And I have 2 minus 2 sine squared x equals 2 plus sine of x. And I think I need to get everything to the left and set it equal to 0. I'm going to subtract a 2 and a sine. That's a sine right there. There we go. I missed the top arc. There we go. Minus 2 minus sine of x. Okay. On the left, sorry, on the right, I now have 0. On the left, I have a negative 2 sine squared. Minus sine. And notice that the positive 2 and the negative 2 are canceling out. Okay, so at first it looked quadratic, but I don't think it is. I think what I have is a greatest common factor. I do see both have a negative in common and a sine in common. Negative sine of x, that would leave a 2 sine in the first term and a plus 1 in the second term. Right? So now I'm going to set them both equal to 0. Negative sine of x equals 0. And when I multiply or divide both sides by a negative 1, I have sine of x equals 0. I am one step away from having the solutions to x. Now, we're getting pretty good at this. 2 sine of x plus 1 equals 0. Let's subtract a 1 and divide by 2. I am one step away from having the solutions here. Okay, I think we've done sine of x equals a negative 1/2. Haven't we? No, I'm not sure. That's okay. We're just going to go ahead and do it anyway, right? So let's do, first of all, sine of x equals 0. Okay, let's draw a little picture. Sine of x is 0 at 0 and at 180 degrees. Notice then, sine is 0. That sine is 0 at 0, and it actually repeats every 180 degrees. So for my first, where sine of x equals 0, I'm going to say that that happens, I'm going to do this in degrees, every number of 180 degrees, right? If my n is 0, I get a 0. If my n is 1, I get 180, and it keeps repeating every 180 degrees. Now, let's see where sine of x equals a negative 1/2. Not that we need a separate picture, but we will. Sine is a negative 1/2. First of all, sine is 1/2 at pi over 6. Am I right? Just checking, don't want to make any silly mistakes at the end, right? So sine is 1/2 at pi over 6, right? Or 30 degrees, right? So, and sine is negative in the third quadrant and the fourth quadrant. So we're at 30 degrees here and 30 degrees here. Okay, what are those solutions? That is 210 degrees, 330 degrees, plus any number of 360 degrees. And our total answers then are these two circles combined. Thanks for hanging out with me. Have a great day.